All right, ladies and gentlemen, welcome to the next lesson in Algebra 1. Today is either going to be Monday the 18th or Tuesday the 19th. Today we're talking about reasonable domain and range. In our last class, we talked about graphs that look like this and figuring out the domain and range. Remember, the domain is the x-axis and the range is the y-axis. And what we did in the last class was some of us put a frame around this. Another way to do that would be to transfer, if we're looking for the domain, transfer this information for this line graph, this segment, to the x-axis. Since the domain is the x-axis, transfer this to the x-axis. Open dot at 3, negative 3, open dot at 3, and then the line goes all the way in between. So my domain is from negative 3, open dot is less than, x, open dot, less than 3. We do the same thing for the y-axis. We always start at the bottom. We always start at the lowest value. We're going to transfer this information to the y-axis. Open dot at negative 2, open dot at 4. The line is all of the stuff in between, which means that my range starts, the lowest value is negative 2, open dot, y-axis, open dot, value of 4. So we can write the domain and range. And the domain and the range is everything in between the endpoints. But we need to learn about how to find the domain and range of something that looks like this. Here, the line was continuous. And let me draw one more line to make a point. If I have something that looks solid dot with an arrow, we know that this arrow means infinity. It's going to keep going forever and ever. When I say continuous, I am not talking about the arrow. I do not care about the arrow. Continuous means that I am connecting all of my points together. I've got a line that connects all of the points. I've got a point here on the line, and here, and here, and here, and here, and here. How many points are on this line, just from here to this solid dot to the edge of my finger? How many points is that? There's a point here, and a point here, and a point here, and a point here. How many points make up this line? Point here, and a point here, and a point here, and a point here. There are an infinite number of points between this solid dot and the edge of my finger. It has nothing to do with the fact, yes, this is going on for infinity, or it's going towards infinity, but really when I'm talking about continuous, the word continuous has nothing to do with what's happening at the end, and it has everything to do with what's happening right here in the line that we're looking at. There are an infinite number of points in this little spot, and continuous means that all the points are connected. But here, do I have connected points? I do not have connected points. This is a discrete graph. So if you see a solid line with connected points, it's continuous. If you see a graph where the points are not connected, this is a discrete graph. Points not connected. Continuous is I draw a line and I connect all my points. Discrete, I just have points and I do not connect the dots. I do not connect the points. I'm going to explain why in just a second, because the reason why, the difference between a continuous and discrete, the reason why I connect the dots or I don't connect the dots has everything to do with reasonable domain and range. I'm going to explain that in just one second. But before I explain that, let me show you how to write the domain and range for a discrete graph. These inequality symbols, and by the way, when we have a continuous graph, we use inequality notation because we have to use inequalities. And the inequalities help us understand that I'm talking about all of the points, all of the infinite number of points between -2 and 4. Let's talk about all the points that are in between -2 and 4. There's -2, there's -3, there's -3.5, -3.5, -3.54, there's -3.547, there's -3.5472. Do you get the idea? I can make these as small as I want, and I can find an infinite number of points on this line. But I can't do that with this one. So I can't use inequality notation because inequality notation helps me understand that there's an infinite number of points between -2 and 4. But let's talk about the domain. The domain is the x-axis. And on the x-axis, I've got a value of 3, and I've got another value of 3, or -3. And here I've got a value of 3 and another value of 3. So all of my values right here are either -3 or 3. So there's nothing in between. There's nothing except x values of -3 and 3. And therefore I just make a list or a set. In math class, a list of numbers is just called a set. Let's think about this. Let's look at this point right here. This point right here is -3, 1. This one right here is -3, 3. This -3, I'm sorry, -3, -3. This one right here is 3, 3. And this one is 3, -2. So if I just look at the x values, the domain, I've got -3, -3. I've got 3 and 3. There's no more x coordinates. There's no more x values. So instead of writing trying to figure out all of the decimals and all the little small points that are on this line, I'm only worried about -3 and +3. So I write a list of these values, these two values. And this is called set notation because I'm writing a set. I'm writing a list of numbers. Notation. And I'm going to do the same thing for the range. Do you think you can do the range? All we're looking at is the actual y coordinates, the y values. The y values, the range, would be 1, and I got to use a little squiggle. Sometimes I can't squiggle very well. If you just squiggle, then that's okay. 1, here's another one, -3, here's another one, 3, and here's another one, -2. Then I close my squiggle. Set notation has to be in squiggles. The squiggly brackets help you know that this is a set, this is a list of numbers. So you see the difference between inequality notation and set notation. Here I'm trying to describe all of the different points that are on the line, and they can be all kinds of decimals. But here I don't have that. I have specific values, -3, -3, 3 and 3. I have 1 and -3, 3 and -2, and those go in the domain and in the range. Well, now that we have just a little bit of understanding of the difference between continuous and discrete, let's help us figure out how to know the difference in a reasonable way. Okay, let's talk about process first. So process-wise, I'm going to give you 5 steps that we need to write down. Step number 1 is we need to identify the independent variable. Identify the independent variable. We need to identify the independent variable. Second step, you guessed it, we need to identify, if we're trying to find the independent variable, we need to find the dependent variable. The independent variable is the x, the dependent variable is the y. We're trying to find the cause and the effect. The third thing we need to do is we need to figure out if the independent variable, and I'm just going to write IV for independent variable, the independent variable is counted or measured. Counted or measured. And let me come over here and write a little note about counted or measured. So counted numbers can be whole numbers or integers. Whole numbers are 1, 2, or 0, 1, 2, 3, 4, and so on. Integers are whole numbers but with negatives. -3, -2, -1, 0, 1, 2, 3. Now, once we figure out the independent variable, we need to ask ourselves, is it counted or measured? Do you count the number of people in the room, or do you measure the number of people in the room? Do you count the ears of corn on a corn stalk, or do you measure the ears of corn on a corn stalk? Do you count the number of popsicles in the popsicle box, or do you measure the number of popsicles in the popsicle box? Do you count money, or do you measure money? So we've got to ask ourselves, is the independent variable counted or measured? So that's counted. Measured are decimals and fractions. Decimals and fractions. Do I count weight, or do I measure weight? Do I count height, or do I measure height? Do I count temperature, or do I measure temperature? Once we figure out what the independent variable is, we ask ourselves, is it counted or is it measured? Because if something is counted, then what that tells us is that is a discrete function. It is a discrete function. Sorry, let me leave the paper right here. If it's a discrete function, then what that tells us is that we need to use set notation. Remember, a discrete function is one where you don't connect the dots. So this is a discrete function. We don't connect the dots. And when we have a graph or a situation that is discrete, we need to use set notation when writing the domain and range. If the independent variable is measured, then what that means is that it's a continuous function. And a continuous function is something where if we graphed it, we would connect all the points together. A continuous function is measured. It has numbers that are fractions and decimals, which means that we need to use inequality notation. Inequality notation. Excuse me. Step number 4. What numbers make sense? What numbers make sense? And I'm going to describe that when we do this example in just a moment. And then finally, the last step is to write the domain and range. The last step is to write the domain and range. So let me move this up a little bit. So for this example right here, let's follow these 5 steps. We need to identify the independent variable, identify the dependent variable. Is it counted or measured? And that tells us what notation to use. And then we got to figure out what numbers make sense, and then we can write the domain and range. Or in this case, just the range. The table below shows, sorry, that should be shows. The table below shows the number of fish at a given depth in a pond, where the number of fish is f of x, so this is fish, and the depth is x, so this is the depth. Okay, so step number 1, what is the independent variable? What is that? That's right, it is depth, because it talked about right here, it says, and the depth is x, so x is depth. Now, do we measure depth? I'm sorry, step number 2. the dependent variable happens to be the other one. It's fish. Step number 3. Now I got to ask the question: Is depth something that we count or something that we measure? Depth, we measure it in feet, we measure it in miles, we measure it in yards. We measure depth. We measure depth, and that means that it's going to be a continuous function, and that we need to use inequality notation. INEQ, inequality notation. I'm just going to abbreviate it. So number 4, what numbers make sense? Well, if I'm looking at the range is all of these numbers. Remember, when we're doing domain and range with inequalities, we need to have a number, a symbol. We're doing the y-axis, another number, and a symbol. So the numbers that make sense are 4, that's the lowest number I have, 4, and the other number that I have is 9, that's the biggest number I have. So if 4 is the lowest number and 9 is the biggest number, that's what I need to put in my domain and range. Now, is 4 an actual number of fish in this situation? Yes, it is. So since it's an actual number in the situation, it has to be included. It has to be less than and equal to. Is 9 fish? Is that an actual number in our situation? Yes, it is. So it has to be equal to, since it's a part of the situation that we're talking about. And that would be the answer. So 5-step process. Figure out the independent variable, the dependent variable, and then you got to ask yourself, is it counted or measured? And once you figure out if it's counted or measured, that's going to help you figure out what notation to use, either set notation or inequality notation. We got to figure out what numbers make sense in the situation. And then once we figure that out, then we can use the correct notation to actually write the domain and range. Let's do another example. Let's do this one. Step number 1, what is the independent variable? Let f of s equal 3s, where s represents the speed in miles. So s is speed, the miles per hour of a car, and f of s represents distance. So f of s is distance that the car travels. If the car's maximum speed is 75 miles per hour, what is a reasonable range? We want to find the range of the function. So the independent variable is s, because this is in function notation, s and f of s. So that's speed. The dependent variable is distance. And now, is speed counted or measured? Do we measure speed or do we count speed? If we're talking about speed, we're talking about velocity, we're talking about miles per hour as you're driving down the street. And you look at your odometer and it could be 37 miles per hour, it could be 36 miles per hour, it could be 38 miles per hour. But it could also be, our speedometers don't normally say this, but it could be 37.5 miles per hour. It could be 65.4 miles per hour. So speed is measured. All right, think about it this way. When the police officer is trying to figure out what speed you're going, he uses a radar gun. And that radar gun is measuring the speed that the car is traveling. So it's definitely going to be measured. So now that we know this is going to be measured, it's going to be continuous. It's going to be a continuous function, which means that we need to use inequality notation. And that's good because all of our answers are in inequality notation, so that's a good thing. We've done this correctly. And we're looking for the range. And look, all of these are y. Y is the range, so that's good. All of these are range values. Now the 4th step is what numbers make sense. What's the lowest number that makes sense? And what's the highest number that makes sense? What's the slowest speed you can go? Just think about this for a second. What's the slowest speed that you can go? Can you go negative speed? Can you go negative miles per hour? I mean, you can go backwards. Your car can go backwards, but you're still going like 6 miles an hour when you go backwards. It's not negative. So the lowest miles per hour that you can go is 0. Okay, well, what's the highest miles per hour you can go? Oh, I'm sorry, we're talking about range. We're talking about range. Range is distance. We're not looking for speed. We're looking for, I apologize. We're going to start over. We're going to start thinking about this and not make mistakes. So when we're talking about range, we're talking about distance. I need to know what is the lowest distance I can travel. What's the lowest distance that you can travel? What's the smallest distance that you can travel? Can you travel negative distance? Again, you can go backwards, but if you go backwards 3 feet, you've traveled 3 feet. You want a distance of 3 feet. So the smallest distance I can travel is 0. Oh, wow, that worked out. So it's still 0. Distance, the smallest distance you can travel is 0. Now, according to the situation here, what's the highest distance you can travel? Well, here's where the number comes in. See that number right there? That number is speed. Speed is s. So if this is the maximum, the highest, the maximum speed, if this is the biggest number of s I can have, what's 75 times 3? 75 times 3 is 225. So the highest distance, the farthest distance I can travel is 225. I have 0 and 25. G is my answer. Now, if I were to do this, if I were to look at these on a y-axis, so if this is my y-axis, and this is 0, let's just say this is 75 right here, then what F represents, it represents a solid dot, and everything in between. G represents 0, and then like 225 is way up here, and everything in between. If I were to graph this on a number line. Let's look at this one for a second. This one's a little weird because in last class we dealt with something that looked like this, not something that looked like this. So it says y is less than 75. So for h, I've got the number 75 and it's equal to, so that's a solid dot, and it says all of my y is less than. All of my y is less than. So I'm going down because that's less than. Going down because that's less than. Going down because that's less than. So this option is G. This is H. No, I got that mixed up. This is F. This is G. And I'm representing H on the number line. And it says Y. All of my Y right here is less than 75. So when should I stop? I shouldn't. What this means right here is that it's going down to infinity. So what this really means is I could rewrite this as negative infinity, less than Y, less than or equal to 75. And those are the same things. Let's do the same thing with J. J says, option J says, all of my Y values are greater than 0. Well, there's 0 right there, and it's equal to, so it's going to be a solid dot. And all of my Y values have to be bigger than 0. All of my Y values have to be bigger than 0. All of my Y values will be bigger than 0. When should I stop? Oh, I shouldn't. What this means right here is it's going to go to infinity. So I could rewrite it. Remember, if I flip it over, it would be 0 less than or equal to y. These two mean exactly the same thing. They mean exactly the same thing. I just flipped it over. Less than positive infinity. These two mean exactly the same thing. So sometimes you'll see it written where they'll just leave off the infinity because you're supposed to know that it's just not going to stop. Let's do one more example. Let's talk about this one right here. A set of weights includes a 4-pound barbell and 6 pairs of weight plates. Each pair of plates weighs 20 pounds. If X pairs of plates are added to the barbell, the total weight of the barbell and plates in pounds can be represented by this function. 20 times X plus 4 equals the total weight. What was X again? X is the number of pairs of plates. So this is pairs of plates, or the amount of plates that you put on each side of the barbell. This is total weight. Okay, total weight, that's good. And then it says that and I'm doing the steps and I'm not even thinking about it. I just always figure out what x and y are. 20, there's the 20 right here. Always try to figure out what your equation is talking about. Each pair of plates weighs 20 pounds. So for each pair of plates that I put on, I'm putting on 20 pounds. That's why these are connected together. So it's always going to be, if I put on 3 plates, 3 times 20 is 60, so it's going to be 60 pounds. And then the barbell itself, the bar that you put the plates on, that's 4 pounds. So that always has to be there because you're always lifting at least the bar. Okay, so those are all the parts of the equation. Now let's work the problem. Step 1, what's the independent variable? The independent variable is x, which we said was pairs of plates. I'm going to put plates. Step 2 is the dependent variable. We said the dependent variable was f of x. We said that that was the total weight, like in pounds. And then step number 3 is the independent variable plates counted or measured. Do you count the number of plates or do you measure the number of plates? We're going to count the number of plates. We count. And counting means, go back to your notes and look at your first page of your notes. Counting means what? Counting means discrete. And discrete, what notation is that? Is that set notation or is that inequality notation? It's set notation. Oh, and look, I mean, we're doing this right. Does this start to make sense? Because look, all of our answers are in set notation. So we need to figure out what we're trying to do. So what numbers make sense? Well, what are we looking for? What is the range? Range was what? Range was weight. Range was weight. So what numbers make sense? What makes sense? Well, if I'm looking for the lowest number, what's the smallest number of weight that we can have? Because we're looking for weight. If I have no plates on the bar, how much does that weigh? Well, the bar itself weighs 4 pounds. So the lowest number I can have is 4. And then it says the biggest number, I can have as many as 6 pairs of plates. So the highest weight, the most weight I can have, can't spell highest, sorry. The highest weight I can have would be 6 times 20. 6 times 20 is 120. 120 plus 4 is 124. So the highest number is 124. So do I have any answers that go from 4 to 124? Well, yeah, we're going to get rid of this. We're going to get rid of that. From 4 to 124. Okay, well, this one has 1, 2, 3, 4 numbers. And this one has 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 7 numbers. Huh. Well, this one has 4 numbers. This one has 7 numbers. Interesting. Well, the range is all the possible numbers. Possible numbers. So let's think about this. The number 4 came when I had 0 plates. If I put 1 pair of plates on there, 1 pair of plates would be 1 times 20 plus 4. Okay, that makes sense. If I have 2 pairs, 3 pairs, 4 pairs, 5 pairs, 6 pairs. These numbers make sense. In option J, I'm missing numbers. So this is if I have 0, but look, this is if I have 2 plates. Well, what happens if I have 1 plate? Where's that number? It's missing. It's not there. So J is also the wrong answer. G is the correct answer. Let's do one more, and then we'll be done because I want to take us through this real quick. Because this one, there's no answer choices. I want us to be able to write the range all by ourselves. A baseball player hits a pop fly ball toward left field where it is caught by a player at a height of 5 feet. 5 feet. The ball was hit at a height of 3 feet, and it reached a height of 50 feet. The height of the ball is a function of time. Okay, the height of the ball is a function of time. What is the range of the function? So first thing we need to do is figure out the independent variable. And it's kind of right in here. The height of the ball is a function of time. So height is going to be the y and time is going to be the x. Because height is a function of time. Time is the cause, this is the cause, and this is the effect. Height is a function of time. Time is the cause, height is the effect. So this is going to be time. The dependent variable is going to be the height. Number 3, do we measure height? Because we're looking for the range. Do we measure height or do we count height? We measure height. We measure. Okay, that's good. Which means, what kind of note? Is this going to be a continuous function or a discrete function? Continuous function or discrete function? It's going to be continuous. A continuous function uses what kind of notation? It uses inequality notation. Good. Now we know how to write it. Now we just got to know what to write. Step number 4, what numbers do we use? What numbers make sense? Okay, so in situations like this, I like to draw pictures. I have no clue what's going on here. So if I just draw an axis here, right, then it says the ball was hit at a height of 3, so that's where it starts, is 3. It starts right here. And then it says it's caught at 5, so 5 is just a little taller. It's caught at 5. And then what does it do? It goes up to a height. How high did it go? It went to a height of 50 and then came back down. Oh, okay. This kind of looks like a problem we can do from yesterday, right? We can do from last class. Okay, so we know this is 3, we know this is 5, and we know that this right here, it got to a height of 50. So what's the lowest number? If we're going to use what numbers make sense, inequality notation, we need a low number, a symbol, the y-axis for range, the other symbol, and then the high number. What's the lowest number on this graph? What's the smallest number? 3. What's the highest number? 50. And then let's think about this. Was the ball ever physically at 3 feet? Yes, it was. So that means equal to. Was the ball ever physically at 50 feet? Yes, it was. So that means equal to. Ladies and gentlemen, in our practice problems today, I want you to be able to answer all 5 questions. So on the practice problems, don't write any of the problems down. Your work in your notebook needs to look like this. I need to see the answers to all 5 questions, okay? And then usually the 5th question, if it's multiple choice, you just put the answer. And if it's an open-ended question like this, then you actually have to write the domain and range or whatever it asks for. So write all 5 steps in your notebook for every single one of the practice problems.